Hello everyone and welcome back to the channel. Today we're going to be checking out a 24 volt 3000 watt inverter from ALFFAA. So let's go ahead and open it up and see what we got. Okay, when you first open it, you will see a one-sheet instruction manual for operating instructions. There's an attention section, safety warnings, after service, product structure, and AC output indications. So here is your instructions, and you also get your inverter. Now the one thing that I noticed is that's it. You don't get any wires. You don't get any conductors whatsoever for this inverter. So make sure you have your own wiring when you purchase this inverter. Okay, my first impressions are not good so far, even though I do have an ALFFAA 1500 watt 12 volt inverter, and it does me pretty well. But these instructions that came with it, they just don't pour out confidence, I guess. There's several misspellings. They misspelled battery and negative. And I'm sure that they're just using some sort of translator program to write this out. But here at the bottom right here, it does say under safety warning, it says, please only use the cable attached with this product. Do not use other cable to prevent any damage or dangerous happened. Well, I didn't get any cabling with this product, so that doesn't even apply. So I think ALFFAA should put a little bit more attention into their small operating manual here. Now let's look at the inverter. Okay, so the front here, it says ALFFAA 3000 watt power inverter converts 24 volt to 110 volts. So you're not going to be getting 120 volts out of this inverter. And we will test it to make sure. AC outlet 3000 watts. Speaking of ports, here's what the AC side looks like. We have a small display that will show us the voltage of the AC output. And I believe this shows us the voltage of the DC input, which is your battery. But when we turn it on, we'll find out. You have two 20 amp AC receptacles right here. You have your power delivery port, your USB-C port right here. It says power delivery 3.0. And then a quick charge 3.0 right here. And you also have your off-on switch right here. On the other side, we have two fans, and we have our battery connections. Now, I personally don't like these. I would rather not have something that you are expected to just kind of hand tighten. I mean, these are not made for a tool. They're made to just hand tighten. And I personally think that connections like these, when you're talking 3000 watts, even though it's 24 volts, I feel like it should be, it should have a torque measurement. The whole case is made out of aluminum, which it should be. That's good. And we'll be opening up this case a little bit later to show you the internals. Since this inverter is 24 volts, we're going to be grabbing a couple of 12 volt batteries and connecting them in series to give our 24 volts. And we'll start testing the capacities of this inverter. Okay, a couple of things I want to go over before I complete the wiring of this inverter is when you're connecting two batteries, two 12 volt batteries in series, you'll be wanting to connect the negative of one to the positive of the other, and that pretty much makes it so it turns it into one battery. So this connection right here makes it so these terminals should measure out at, 26, 27 volts, depending on how much charge you have in your batteries. So let's go ahead and measure it out first, because you'll want to check that to make sure that your battery bank is the voltage that you want. And our voltage is 26.3, so that is perfect for this inverter. This 24 volt ALFFAA inverter does have a shutoff of under 20 volts, or if it goes over 30 volts, give or take a half a volt. And then when you're connecting your inverter, you always want to put your conductor on first, and then your flat washer, and then your lock washer, and then tighten it down. All right, and also since this is a 24 volt setup, you definitely want to use a resistor so that way you don't get a huge spark when you're connecting it to your negative connection on your battery bank. So let's go ahead and put this on here. Hold this down. We'll put the resistor right here. And when you do this, make sure your inverter is turned off, because if it's on and you do this, as soon as you take off the resistor, the inverter will get discharged because it's on, and when you go to connect it, you'll get a big spark. So make sure your inverter is turned off. So let's go ahead and touch these. And you only need to do it for just a couple seconds. I like to do it for like at least 5 seconds. It just makes me feel better. So once you do that, you connect it up and you should not see any spark whatsoever. All right, tighten it down so none of your connections should move. That's why I don't like these hand tightened connections, because even though I've got it as tight as I can go, I can still move this. And I feel like that can cause issues in the long run. So just keep that in mind. All right, our inverter is ready to go. So let's go ahead and turn it on and see what it does. All right, it looks like it does like a little fan run to make sure it works. And it looks like we have a green light that shows power. Again, we have 112 volts coming through the AC. This is the amperage right here, so that would be the amount of amps coming out, maybe? I don't know, we'll have to find out. And then here is the voltage of the battery bank. Let's see how accurate this is right here. All right, and it looks pretty accurate. I've got a 26.75 and this shows 26.7, so we're good there. And then on the AC side, it shows 111.7, and this shows 112 volts. So these screens seem to be pretty accurate so far. All right, when it comes to standby consumption, it looks like it's using about 0.27 amps. And if you multiply 0.27 by the voltage, which is 26.7, you get a little over 7 watts of standby consumption. All right, check out this monstrosity of a testing environment. All right, there is the Alpha 24-volt inverter. It's connected to those batteries. I have an amp clamp that is connected to the 24-volt cabling, so we can watch all of the amperage coming out. We also have our voltmeter connected to the batteries, so we can see the voltage of the batteries as this test goes on. I have my AC meter right here, so we can see what the voltage is coming out of the AC. And we do have a pure sine wave right here currently, and we will be watching that to see how it handles higher and higher loads. What I have connected to this inverter right now is a new wave induction cooktop, which I will be starting off at high, which is 1300 watts. I have this Cuisinart Griddler Jr., which pulls about 1100 watts. I have a 500 watt heater and a 200 watt heater. So to begin this test, what I'm going to do is I'm going to turn on my induction cooktop on high, which is 1300 watts, and I will be connecting this 200 watt heater also. So that'll be about half the load of this inverter. And I'm going to be running it for about 10 minutes. So 10 minutes, I feel like it should be getting about as hot as it possibly can. And we're going to look at a thermal camera and we're going to look at all the connections to make sure that everything is still okay. All right, so let's go ahead and start. Our amperage currently is about 0.5, and that is because the induction cooktop is actually on. That's not the standby consumption of the inverter itself. And our voltage is at 26.7. So let's go ahead and turn this guy on high. There we go. And turn on our 200 watt heater. Voltage of the batteries is down to 25.7. And the amperage is right around 57, 58 amps. Now that will start to lower back down once this heater gets up to speed. Our sine wave is still very good. Let's go ahead and start this timer. And the voltage coming out of the AC side is right at 110 volts. So that is looking good as well. All right, and just a little update after 4 minutes. Our batteries are at 25.23 and our amperage is 62.5. And let's go ahead and calculate the efficiency of this inverter while we're doing this test. Right now on this plug, which is powering the new wave, it is running at 1288 watts. And this heater right here is on this plug, and it's powering 192 watts. So let's go ahead and add those together. So that's 1480 watts coming from the AC side. So let's go ahead and calculate the DC side, and we'll be able to figure out the efficiency of this inverter after doing that. So what we need to do is find the amperage, which is 62.5. So we'll say 62.5, and we need to multiply it by the voltage. And we need to multiply it by the voltage, which is 25.23. So 25.23, and that gives us 1576.87. So now you need to divide the AC side by the DC side to get your efficiency. So 1480 divided by 1576 equals 93.9. So a 94% efficiency rate. That is pretty good. All right, well, it has been 10 minutes, so let's go ahead and pull up the thermal camera and check our temperatures. Okay, here is what the inverter looks like just from a faraway glance. It's 87 degrees Fahrenheit, which is room temperature. Oh, and the fans just turned on. You can see that the AC outlet for my induction cooktop is actually 130 degrees Fahrenheit, which is pretty warm. And you can see my induction cooktop is boiling water right at 206 degrees. Let's see where the DC connections of the inverter. These are actually pretty warm. They're 150 degrees Fahrenheit. Yep, 150, 130. And the fans, when you tap them, they kind of make a an odd sound, but whatever. Yeah, and you'll notice that the cabling is getting heated up from this connection right here, because as it goes up, it cools off a little bit. You know, the cabling's only 60 degrees, and the connections on the batteries, you know, it doesn't even care. I mean, it's room temperature connections at the battery terminals. And then the terminal over here is actually a bit warm. That's 111 degrees. But the connections here are pretty warm. I'm surprised that they're 150, 145 degrees. And that's only half capacity for this inverter. And just to tell you, we're only pulling 54 amps. So these 4-gauge cables can handle 54 amps just fine. All right, so the next thing I'm gonna do is I'm gonna go ahead and just push this thing to its limit. I've got enough here to do about 3,100 watts of power. So let's go ahead and just do that and see what happens. So what I need to do is turn on this small heater here. And with that 500 watt heater on now, we are up to 74.7 amps. Let's go ahead and turn on the griddler and see what happens. And it shuts it off. That was about 3,100 watts of power. And the inverter knew it was going over its 3,000 watt limit, and it shut everything down. And actually, I'm wrong about that. The voltage at our batteries is at 2.6 volts. So the batteries actually shut off. So I'm gonna have to get a couple of bigger batteries and do this high amperage test again. All right, well, I got 2 different batteries. I've got the Orient Power battery, which has actually a 200 amp BMS, and the Cyclone battery, which is like a mini, but it has 120 amp BMS, and I think I remember reviewing this and I couldn't get this thing to shut off. So I'm thinking that these batteries can handle the 3,000 watts I'm about to throw at this. And also I reconfigured my meters. So one meter will be powering the new wave, so we'll be able to add that to this one, which is powering everything else. Now, okay, I've got to say, don't do this in real life. This is a bad setup. Don't use completely different sizes of batteries connected in series that have two completely different BMS over amperage protection settings. You'll just run into a whole bunch of trouble. I mean, that's also a 230 amp hour battery. That's a 100 amp battery. Just don't do it. This is only for testing this inverter, and I won't be doing this for very long. I just wanted to put that out there. Okay, so let's go ahead and start. We have a voltage of 26.44, and our amperage is pretty much at 0.5 amps because we have our new wave sitting on idle. So let's go ahead and just turn everything on, try to see if we can get our 3,000 watts, hold it there for maybe a minute or two, and then we'll see what happens. Okay, so we're gonna start our induction cooktop now. Max sear, start. Turn on our two heaters. All right, and with that running, what we have is, it looks like 1,220 watts plus 650 watts. So that's like right around 1,900 watts right there. Our amperage is 84.5 amps. So hopefully these batteries can do it. They're at 25.19 volts. So let's go ahead and power this on. Full blast. This is another 1,100 watts. Hit start. Something's beeping, but I'm not sure what. But we have 1,245, oh, and 1,636. So that is right at 2,880 is what we have. So we have 2,880 watts from the AC side right now. And we are powering 134 amps going into the system. The batteries are down to 24.5. But everything seems to be running. And amazingly, the temperature, the inverter, the fan on the inverter is not even on yet. So it doesn't care what the wattage is. It must have a temperature probe inside that will turn on once the temperature gets up to a certain degree. Yeah, these are only 4 gauge cables. So 130 amps is kind of high for these. Yeah, we're still powering 2,880 watts from the AC side, and the fan just turned on. The DC side is right at 3,269 watts coming from these batteries. It's been over 2 minutes. Let's go ahead and check out the temperature. All right, the temperature of the unit, we are looking at oh wow, look at that, 260 degrees. 270 degrees Fahrenheit. So that is really hot. Battery connections are less than 100 degrees to the inverter. The cable connecting the batteries is right around 100. Is right around 115. But yeah, this connection right here, that connection right there, that's scary. That's hotter than the water over there. So let's go ahead and turn this off. All right, so let's go ahead and take a look at the inside of this inverter. Now, mind you, I am not an electrician or an electrical engineer, so I don't know what a lot of this stuff does, but I do want to give you a view of the inside for the people that do know. And they can leave something in the comments describing something either good or bad about the internals of this inverter. What I do know is that the cabling on the positive, well, I mean, it's four positives, but it does show, looks like 4 millimeters squared cabling. We also have 2 heat sinks right here. I do notice that they have plenty of glue on all the connections, so that makes it so they won't shake out, which I guess is good. They have 1 fan right here and then 2 more fans in the back. And actually this one right here is a double fan. And actually on the negative side, it looks like they're using 3 6 millimeter cables. So 4 4 4mm cables on the positive and 3 6mm cables for the negative on the DC side. On the AC side, it looks like the wiring is 600 volt 16 gauge cable. They do have zip ties on some of their wiring, but it still looks like it's kind of a little messy, but at least they do have zip ties on everything to keep it secure. All right, and here's one more view. All right, so what do I think of the Alpha 24 volt 3000 watt off-grid inverter? I'm happy that it was able to power everything that I wanted. You know, it kept that consistent 110 volts, and I was able to push it all the way up past 2800 watts, and it didn't have a problem whatsoever. I guess I should say it didn't have a problem powering the devices that I wanted it to. The problems that I see are, well, these connections right here. I don't like these finger tight connections for the DC side. I just don't feel like I got a very good clamp on it, and I think it shows by the temperature. I mean, those things got hot. You know, the connections to the inverter were 260 degrees Fahrenheit when the connections to the battery were only at, you know, right around 100 to 110, something like that, which is a huge difference. And that was only running 2800 watts for 2 minutes. I mean, they would just get hotter and hotter and hotter the more you ran that much current. And I think the current was like 134 amps. Also, the documentation, it could be better. I knew exactly what they were talking about, but just the misspellings and stuff like that, you could easily fix that. And also in the documentation where it says to only use the cabling provided with the inverter when there wasn't any cabling provided with the inverter, is kind of a bummer. So if you have any questions about the 24 volt 3000 watt pure sine wave inverter from Alpha, please go ahead and leave them in the comments. I'll have a link to this item in my description just in case you want to look further into it. Thank you so much for watching this video, and have a great day. Bye-bye.